Hello and welcome to another exam paper walkthrough. Today we are focusing on these really great set of papers from PixiMaths, and today we're doing the set Bs. So when these were produced, they did a set A, which I did on Tuesday, and then the set B is what I'm aiming to do today. Really good paper. The set A's were really good. I'm sure the set Bs will be just as good. PixiMaths is a really excellent revision site. I use it a lot with my year 11s. They do a lot of scaffolded worksheets, which I'm a real big fan of. So check them out. I'll put a link to their site in the description. Okay, question 1 then. Work out 27 plus 38. So we're on a calculator paper, so even though that seems pretty obvious, there's no advantage to actually working it out other than using a calculator. So when we add them together, we get 65. So 65 becomes my first answer. I need to turn my pen on. What colour should we go for today? Let's go start in blue. So 65. And for the second one, we're looking at subtraction. So 202 minus 75. 127, and then 2 times by 3 times by 2 times by 3 times by 5 would give us 30. Okay, question 2. Write down the ratio of 450 grams to 15 grams. Giving your answer in its simplest form. So I tend to simplify this using my calculator. I'll type it in as a fraction with the smaller one on top. So I'm going to go 15 out of 450, and my calculator will automatically simplify that down to 1 out of 30. So my simplified ratio is going to be 30 to 1. Okay, and question 3. A is 3, B is 5. Work out the value of 4A plus 2B. So I'm going to write down what I'm going to type into my calculator. So 4 times by 3 plus 2 times by 5. And then I'm just going to type that into my calculator just like that. The calculator will automatically do the orders of operation, so it'll do the multiplication before it does the addition. But we're going to get 22 for that. Okay, question 4. In the space below, draw a sketch of a rectangle. So a sketch of a rectangle doesn't need to be anything too complicated. We're looking for 2 pairs of parallel lines and 4 90-degree angles. Just to make that clear, I'm going to indicate we've got right angle, right angle, right angle. Well, I'm sure you don't need these. Same length, same length, same length, same length. Okay, part B, write down the mathematical name for the straight line inside the circle. So that is going to be a chord. And then here is the solid shape. Write down the mathematical name of the solid shape. That is going to be a cylinder. So there we go. Okay, question 5. Pat and Julie share some money in the ratio 2 to 5. Julie gets £45 more than Pat. How much did they both get? So we're saying, in a sense, 2 to 5. Well, the difference in their ratio is going to be 3 parts. So Pat got 3 more parts than Julie. So those 3 more parts are worth £45. So if I do 45 divided by 3, that's going to give me 15. So each part is going to be worth 15. I should have set this out a little bit better. So that was P and J. And the question asks, how much did Pat get? So that's going to be 2 times 15, which is going to be 30. Okay, question 6. Here is a triangle and a rectangle. The area of the rectangle is 6 times the area of the triangle. Work out the width of the rectangle. So I'm going to call that value x for now. So the area of the triangle is going to be equal to a half of the base times by the height. So a half of 8 times by 9, which is going to give me, so I'll type it in just like that. 1/2 of 8 times 9. So that's going to be 36. The area of the rectangle is going to be equal to 16 times by x, so 16x. So the area of the rectangle is 6 times more the area of the triangle. So in effect, that's telling you that 16x, the area of the rectangle, is equal to 6 times the area of the triangle, so 6 times by 36. So x is going to be equal to 6 times by 36 divided by 16. So I'll type it into my calculator just like that. So I want a fraction, and my numerator is going to be 6 times by 36, and my denominator is going to be 16. Could do some simplification here, but there's no advantage on a calculator paper, provided you type everything in correctly. So we're looking at 13.5. So I'm going 13.5. Okay, question 7. So Jeremy catches 19 fish. Here are the weight in grams. Draw an ordered stem and leaf diagram for these weights. So an ordered stem and leaf diagram it's always a 3-mark question. It's always 1 mark if you draw an unordered stem and leaf diagram, 1 mark for ordering it, and 1 mark for a key. So I'm going to pick up the first. So I'm going to do an unordered one first of all. So my smallest value from the list looks like it's 40. And then my largest one from the list looks like a 70. So I'm going to go 4, 5, 6, 7. And then in effect, this is my unordered one. So I'm just going to go down them in order. 50 would be a 0 in that column. 61 a 1 in that column. 57 a 7 in that column. 47 a 7. And we just carry on with this process. Quite a slow question to do, but quite therapeutic as you're doing them, crossing them out. Okay, now I've got them all. I need to put them in order. So I've got 7, 8, 8. So let's put my stems in first of all. 4, 5, 6, and 7. And then ordering those, we've got 7, 8, 8. And then ordering these. So I've got 2 zeros. I've got 1, 1, 1, 3, 1, 5, 1, 7, and 1, 8. It's just, if I can make that a little bit clearer. My 6s then, ordering those, they already look in order. So I'm looking 1, 2, 4, 6, 6, and 9. And then my 8s, ordering those 3, 5, and 8. And then my key, I always tend to pick my first one. When I was doing my exams, I used to pick a more complicated one. But as a marker, it just makes it straightforward for you to mark if you choose the most obvious one. So technically speaking, 1 mark for an unordered, 1 mark for an ordered, 1 mark for your key. Okay then, question 8. So let's get rid of my calculator for this. This diagram shows a prism with a cross section in the shape of a trapezium. On the centimeter grid below, draw the front elevation of the prism using a scale of 1 centimeter to 1 meter. So I need a. It just asks for draw the front and the side. There we go. So the front elevation is going to be this trapezium, which is 2 by 2 by a half. So I'm going to go. It says use a scale of 2 centimeters to 1 meter. So if I've got 2 meters, I need to draw a 4 centimeter line, and then 4 centimeter line across. catching. Instead of half a meter up, it would be 2 centimeters up. And then join them up. So that should be my front elevation. And then my side elevation, I'm going to see 1 centimeter across, which it would be, 1 meter across, which would be 2 centimeters. I've got this front edge I would see at 0.5, which would be 1 centimeter up. And then I'm going to see the top edge of the shape. So that's going to be that part there. So that's my front and my side. Okay, and question 9. So ABC is a straight line, DEFG is a straight line, AC is parallel to DG, and EF is equal to BF. Angle BEF is 50 degrees. Work out the size of the angle marked with VX, giving reasons for your answer. So the way that I'm going to do this is I'm going to start by working out this angle here. Because we've got an isosceles triangle, I know that that's going to be a 50-degree angle. So based on that, I can say that angle EFB is going to be equal to 180 minus 2 lots of 50. So that's going to be 180 minus 100. So that's going to be 80 degrees. So that's saying that that's 80 degrees. I'm also going to say that that is angles along a straight line. So angle BFG, one of my daughter's favourite films, and so BFG is going to be equal to 180 minus 80, so that would be equal to 100 degrees. And then I'm going to finish that off by saying that the angle that I'm after, X, is going to be equal to, work out the size of each angle, give a reason for your angles. So I should have put, for this one, actually let's set it out in my normal fashion. So at the side I'm going to explain in, I'll do my explanations afterwards. So X is going to be equal to, so it's forming what's called a supplementary or co-interior angle. So it's going to be 180 minus 180 minus 100. So it's going to be equal to 80. So that's the size of the angle. I've missed out my reasons though. So I worked for this one. I used the fact that base angles in an isosceles triangle are equal, and also I use the fact that the angle sum a triangle are 180 degrees. For my second reason, so let's just separate that slightly. My second reason is angles in a line add up to 180 on a line equal 180 degrees. And then my final one is co-interior angles equal 180. Okay, so there we go. Right, question 10. Right, 168 is a product of its prime factors. You must show your working. Okay, so this is you must show your working. Okay, so this is to avoid us using the factor button on our calculator, which I'll go through with you in a second, but we'll do it without first of all. So 168, if I'm doing it with a factor tree, I would always pick off my lowest factor first of all, so that's going to be 2 times by 84, which is going to be 2 times by 42, which is going to be 2 times by 21, which is going to be 3 times by 7. So if I'm writing it as a product of its prime factors, that's going to be 2 to the power of 3 times by 3 times by 7. If it didn't say you must show your working, I would use the factor button on my calculator. So just to show you how that works, to check my answer, 168 equals, so I've now got that as my answer. And if I use this factor button on my calculator, so shift factor, it tells us that that's 2 cubed times by 3 times by 7. So that's a good way of checking, particularly if it doesn't say you must show your working. Okay, find the highest common factor of 168 and 180. So I'm going to show you a real quick way of doing this on your calculator again. So if I type this in as a fraction and get my calculator to simplify it, so 168 over 180, it's cancelled it down to 14 over 15, and then whatever it's cancelled it down by will be the highest common factor. So if I do 180 divided by 15, that will give me 12. So that's my highest common factor. I can do that with the numerator as well. So 168 divided by 14 will also give me the 12. So that's a nice way of doing it on a calculator paper, finding the highest common factor. Okay, and question 11, the diagram shows the surface of a pond in the shape of a circle. The circle has a radius of 120 centimeters. Mark wants to put 20 fish into the pond. There needs to be a surface area of 1,800 centimeters squared for each fish. Show the surface area of the pond is large enough for Mark to put 20 fish in the pond. So I'm going to work out the area of the pond. So the area of a circle is equal to pi r squared. So in this case, that's going to be pi times by 120 squared. And while I'm here, I'm also going to work, before I go to my calculator, I'm also going to work out the area that each fish would need. So where am I? There needs to be a surface area of 1,800. So we need to have that. So that's really what we're comparing to. So I'm going to do that in kind of at the same stage. So shift pi times by 120 squared gives us a surface area of 45,238.93 centimeters squared, and we need 1,800 times by 20, so we need 36,000. So show that the surface area of the pond is large enough. So I'm going to finish with is large enough as 45,238.93 is greater than 36,000. So that's how I would do that question. My other option, which is perfectly fine, would be to have divided the area by 20 and shown that the area divided by 20 is bigger than 1,800. That would be absolutely fine as well. Okay then, question 12. Here are the costs of the same type of battery in two shops. Shop A, packs of 4, £1.60. Shop B, packs of 6 batteries, £2.70. Harry needs to buy at least 30 batteries. He assumes that he will buy the batteries in whole packs. Harry wants to buy the batteries as cheaply as possible from the same shop. Which of the shops should he buy from? Okay, so if I think first of all, If I do 30 divided by 4, so 30 divided by 4 is going to be equal to 7.5. So if I'm going to shop A, I would need to buy 8 packs at £1.60 each. The reason I need to buy 8 packs is he's buying whole packs, so I can't buy half a pack. So 8 times by £1.60 is going to give me a total of £12.80. So if he bought the batteries from shop A, he would need to spend £12.80. If he goes for shop B, so he can buy them in packs of 6 from shop B. So 30 divided by 6 is going to be equal to 5. So he can buy them exactly from this shop. So 5 times by £2.70 though. 5 times by 2.7 is going to be equal to £13.5. So £13.50. So even though he has to buy more from shop A, it would still be cheaper. So which shop should he buy his batteries from? So he should buy from shop A as £12.80 is less than £13.50. And then let's look at part B. So part B says, Harry's assumption is wrong. He can buy single batteries for 40 pence each in shop A and 45 pence each in shop B. Does this affect which of the two shops Harry should buy the batteries from? Give a reason for your answer. Well, would it affect my answer? No, it wouldn't affect my answer. I'd still buy from shop A. I'd just be paying 80 pence left. So shop A. So does this affect which of the two shops Harry should buy the batteries from? No. Shop A would be an extra 80 pence cheaper. Shop B would be the same. So more information than is needed there, but there we go. Okay, question 13, expand and simplify. Quite a complicated expansion for a foundation paper. So I'm gonna show it on a grid. So because it's quite a complicated one, I think the grid might be the useful way. I'll do it with the construction lines afterwards, or the foil method afterwards. Okay, 2x times 3x would give me 10x squared. 2x times by plus 2 would give me 4x. 5x times by minus 3 would give me minus 15x. And then minus 3 times by 2 would give me minus 6. Then I need to add these 4 things together, which I'm going to do after I've done my second method. So my second method is either referred to as FOIL often, or I refer to it as the construction line method. Just because being dyslexic, FOIL is not an acronym I'm particularly good at using. So 3x times by 2x would give me 10x squared. 5x times by minus 3 would give me minus 15x. 2 times by 2x would give me 4x. And then 2 times by minus 3 would give me minus 6. And then I've still got the same 4 terms. When I add them together, then I get 10x squared. Minus 15 plus 4 would be minus 11x. And then minus 6. And factorize. So I tend to set up factorize in a very straightforward way. It's going to have to go into 2 brackets, both beginning with x. And then I'm looking for 2 numbers that multiply together to make the back term, so 3. And that add together to make the middle term, 4. And my only options really are, because 3 is a prime number, are 1 and 3. And that does work in both cases, so plus 1 and plus 3. So I'm going x plus 1 times by x plus 3. Do also very occasionally, if it's more complicated, set it up using the grid method. So I know that I've got an x squared. I know that I've got a 4 there, a 3 there. So I know that I must have an x and an x there. And then this is the one that I need to consider then to make 3. I can only have 1 and 3. And then that does work. I find that method slightly longer, but if you prefer that method, then whatever works for you. Okay, so question 14. In Spain, Sam pays €27 for 18 litres of petrol. In Wales, Leo pays £40.80 for 8 gallons of the same type of petrol. €1 equals 0.65 gallons. 4.5 litres equals 1 gallon. Sam thinks that petrol is cheaper in Spain than in Wales. Is Sam correct? You must show how you got your answer. Realistically, I want to work out the price of each of them in either, I'm going to go in pounds per litre. So if I start with Sam and I want Sam's price in pounds per litre, so for Sam's price, so starting with Sam, if Sam pays €27 and he gets 18 litres of petrol, I want to convert this into pounds. So the conversion for euros to pounds is times by 0.85. So if I times this value by 0.85, that will give me the price in pounds. So let's go for that. So 227 times by 0.85 gives me, let's bring my calculator back in, gives me, get rid of that calculator. I'll do that again. 27 times by 0.85 gives me a price of £22.95 for 18 litres. So I realistically want the price per litre. So if I divide that by 18, so Sam pays £1.275 for 1 litre of petrol in Spain. Then I'm going to look at Leo's price. Leo pays £40.80 and he gets 8 gallons for that. So I want to convert gallons into litres. So 1 gallon is 4.5 litres. So I'm going to do 8 times by 4.5. So he gets 36 litres for £40.80. So for 1 litre, he's going to be paying 40.8 divided by 36. So Leo is paying £1.13 reoccurring for 1 litre of petrol. So Leo's paid less per litre for petrol. So Sam thinks petrol is cheaper in Spain than in Wales. So is Sam correct? No. No. Petrol is cheaper in Wales. And then I can put the figures in because £1.13 is less than £1.28. And you could have done it a different way. Whichever way you did it, you could have converted it. It's quite a difficult one as a marker because you can either have euros compared to litres, euros compared to pounds, euros compared to litres, euros compared to gallons, your pounds compared to gallons or pounds compared to litres, but you need to have converted them both into a similar format, which would have involved, anyway you did it, it would have involved 2 conversions and then working out a unit price. Okay, and on to question 15. So question 15, buttons are sold in packs. There are 6 buttons in a packet. There are 15 buttons in a box. Namusa buys D packets of buttons and F boxes of buttons. She buys a total of T buttons. Right, a formula for T in terms of D and F. So if we're saying that D represents packets, so that would be 6D. And then if we're saying that boxes, we're using the letter F to stand for boxes. A bit confused about the lettering, but that's fine. 15F. So T is going to be equal to 6D plus 15F. Okay, and question 16. So Anya has £40,000 to invest. She's going to invest in a scheme from either the Building Society or the bank. Anya wants to invest in the scheme that gives the most interest. Which should she invest in? So the first one does invest £40,000 in an account at 3% per annum compound interest for 2 years, and then the other one is that pays 2,550 interest at the end of the 2 years. So realistically, we want to work out how much is going to be. Well, we want to work out the interest from the Building Society because we've already got the total interest from the bank. So in effect for this, I want to do the total money in her account would be 40,000 times by a 1% per annum interest would be a multiplier of 1.03. And I want that to the power of 2 because it's 2 years. So the amount of money that would be in the account would be 40,000 times by 1.03 to the power 2. So there'd be a total of 42,436. So if I subtract from that the initial 40,000, I would have made £2,436. That would be the interest from the Building Society. I'll abbreviate that to BS. So which one has the greater amount of interest? So the bank. Which scheme should she invest in? The bank. As £2,500 is greater than 2,436. Okay, and on to question 17. So let's just make that slightly bigger. So number y is rounded to two significant figures. The result is 0.46. Write down the error interval for y. So in effect, if I just use this to help me. So it's been rounded to 0.46 instead of 0.45 or 0.47. So what we would say is the midpoint of those is 0.455. Midpoint of those is 0.465. So if I'm writing it down, if we had that value, we would actually round it up. So if I write this with my inequality symbols to write the error interval, so the smallest it could be is 0.455, and y has to be greater than or equal to that, but less than 0.465. So that's my error interval. Okay, question 18, solve the simultaneous equations. So for solving simultaneous equations, we either need to make our x coefficients the same size, whether that's a positive or a negative, or our y coefficients the same size. So we could make our x coefficients both 4 or our y coefficients both 3, and that would be a positive 3 and a negative 3, but that's okay, that's what we want. And I'm going to go for that. So to do that, I'm going to call this equation 1 and this equation 2, just to make it clear to whoever's marking my paper the steps that I've taken. So I'm going to do equation 1, and I'm going to times that by 3. So that will give me 12x plus 3y is equal to 75. And I'm going to call that equation 3. So now I've got two equations where I've got 3 y's. One's a negative and one's a positive. So to cancel them out, what I'm going to do is I'm just going to add them together. So I'm going to do equation 2 plus equation 3. That's going to give me x plus 12x would give me 13x. Minus 3y plus 3y would give me 0. And then 16 plus 65 is going to give me 91. So let's just double check that with our calculator. So 75 plus 16 does give us 91. So now I'm going to divide both sides by 13. And that gives me x is equal to 7. So that's my one part. I need to work out my y now. To do that, I'm going to substitute that value for x into one of my original equations. And it's up to me which one I choose. It doesn't really make a massive difference. I'm going to choose equation 1 because it's got no negatives in it. So I'm going to sub x into equation 1. So 4 lots of x becomes 4 times 7, which is going to be 28, plus y is equal to 25. I minus 28 from both sides, I get y is equal to minus 3. And then let's just see how many marks it's worth. So this is a 3-mark question, so I'm going to spend 20 seconds just doing a quick check. And I'm going to check with the equation that I've not already used for the substitution part, so I'm going to check with equation 2. So 7 minus 3 lots of minus 3 becomes plus 9 is equal to 16, so I know that I've got that right. So x is equal to 7, y is equal to minus 3. Okay, and question 19. The graph gives information about the number of litres of petrol in the tank in Jim's car during a journey. So we've got the starting value, we've got it gradually drop in at 3:30, filled back up, and then drop in again. So what questions? How many litres of petrol were in the tank at 1 p.m? So at 1 p.m, we're here, so that looks flat bang in the middle, so I'm going to go 35 litres. At 2:30, Jim stopped and put some petrol in his tank. How many litres of petrol did he put in the tank? So that's where he was. That's where he went to. So 10 to 40 is going to be a difference of 30. So 40 minus 10 is going to be equal to 30. So he put in 30 litres of petrol. And part C, work out the total number of litres of petrol the car used between 1 p.m. and 6 p.m. So the total amount used. So I'll change pen colour just to help me out with this. So we used between this point and this point, we've used 25 litres. And then between this point so I've miswritten that. So we used 25 litres of petrol during the first part of the journey, and we'll change the colour again. And then for the second part of the journey, we went from here to here. So that looks like 15. 15 to 40 is a difference of 25. So I make it 25 plus 25. So they used a total of 50 litres of petrol in 2 separate sections. Okay, and question 20. The table shows some information about the foot length of 40 adults. I'm underlining 40 because it probably will be a key bit of information. Write down the modal class interval. So that just means the group that contains the most. So the group that contains the most is this group here. So write it down like it appears. 22 is less than or equal to F, which is less than 24. So that's the modal group. Calculate an estimate for the mean foot length. So this is where the 40 comes into play. This total should add up to 40. It's always worth double checking. I've seen a few exam papers where they've not got that right. So 9 plus 9 is 18, 20, 30, 40. So it does add up to 40. But we're given that information there. We need the midpoints of each of these groups then. If you're ever unsure how to find the midpoint, you can't do it by inspection. The trick is add the two values together and then divide by 2. So we've got a midpoint of 17 for this group, 19 for this group, 21 for this group, 23 for this group, and then 25 for this group. So I'm going to write this as a single sum. I need to times my midpoint by my frequency for each one and add them up. Then I divide it by the total frequency, which we've worked out in 2 ways. It says in the question, but also we've added it up. So I can type it in just like that. Saves me a bit of time, but I need to double check that I've typed everything in correctly. I have a habit of rushing and not typing these in right. And I've not even written it correctly. I missed the times by 12 there. So hopefully, as I've been extra careful typing it in, and spotted a mistake, if that was the only mistake there. And I want to divide that by 40. So assuming I've typed that in correctly, then I get 21.9 as my estimate for the mean. Okay, question 21. So a gold bar has a mass of 12.5 kilograms. The density of the gold is 19.3 grams per centimeter cubed. Work out the volume of the gold bar, giving your answer correct to 3 significant figures. So the formula for density is given to you in the unit of density. It's a measure of mass divided by a measure of volume. So we want to work out the volume. So rearranging this equation gives us, or if you use a formula triangle, that's absolutely fine. dmv, cover v, and you're left with m over d. So the volume is going to be equal to the mass divided by the density. And the question gives you the mass. And it also gives you the density. And I've just spotted one thing. Have you spotted it? I've made a slight, not mistake. We're given our mass in kilograms and our density measurement is in grams. So I need to convert this to 12.5 grams to do grams into kilogram. I'm times in by 1,000, and I can do that on that line there. Don't need to do it separately. So type it in as a fraction. 12.5 times by 1,000 divided by the density 19.3. That gives us a volume of 6,407.668 ... So 3 significant figures. That's my 3 significant figures. The number behind the 7 is a 6, so I'm going to round it up to 648 centimeters cubed. Okay, question 22. Work out the value of b minus 2a as a column vector. So as a column vector, I'm going to write it like that. So 4 over 2, or 4, 2, minus 2 lots of 3 minus 7. I should have really set this out a bit better. Let me do it again. Give myself a bit more room. So I'm going to write that as 4, 2 minus 2 lots of 3 minus 7. So that's going to become 4 minus 6 over 2 plus 14. So that's going to give me minus 2, 16. Okay, and final question. So here we've got a trapezium. Work out the size of the angle CDA. So let's just mark that on CDA. So I want to work out that angle there. Okay, to do that then, So I'm going to have to do this in 2 stages. So if I call that x, and then we just plan slightly. So my issue is, what I'm going to do is I'm going to create a right angle triangle here, and use Pythagoras to work out the size of that angle. I know that the height of that is 6, but I don't know what this length is here. What I'm going to have to do is, it's going to be 24 take away 10, but then I've also got to take away this distance here. So I've got to work out this distance here. So I'm going to call that y. So if I start that off, I'm going to say that we're using basic Pythag here to find a shorter side. So y is going to be equal to the square root of, actually let's set it out slightly differently, y squared is going to be equal to the hypotenuse squared minus the other shorter side squared. So that is going to be 7.5 squared minus 6 squared is going to give me a value of 81 over 4, which is going to square root quite nicely. So y is going to be equal to 9 over 2. Just double check that. There we go, 9 over 2. Or 4.5, that's absolutely fine to use. In fact, it might be better in this case. So I'm going to call this then, the length here, I'm going to call z for now, just to try and use different letters. So z is going to be equal to 24 minus this length here, so minus 10, minus this length here, so minus 9 over 2. So that's going to be 24 minus 10 minus the answer that I just worked out, so 19 over 2. And again, I'm going to leave it like that because I'm using my calculator. There's no real advantage to going decimal. So I'm going to change pen colour now that I'm moving to my trig section of the question. And then I'm going to try and bring that back. And my calculator back. So if I'm using trig, then, and this is the angle that I'm working with, that means that this becomes the opposite side, and then this would become the adjacent side. So I'm using the tan ratio. So tan is equal to the opposite over the adjacent. So I'm going to say that the angle that I'm trying to work out is going to be equal to tan to the minus 1 of the opposite, which was 6, divided by the adjacent z, which we've said is 19 over 2. And I can use my calculator to type it in just like that because I've got it in my calculator memory. So if I do shift tan and then type in a fraction with 6 as my numerator and my last answer as my denominator, that gives me the size of the angle. So I'm looking at 32.27564 ... So to 1 decimal place, then that's going to be 32.3. Okay, that brings us to the end of this paper. That final question was really nice, a bit of Pythag and trig combined. Really nice paper, really good revision tool based on the topics that appeared on paper 1. I tend to call these prediction papers. PixiMaths prefers to refer them as best guesses. That's just because it's really difficult for teachers or for people writing these exams. If we say that these are predictions and they're not on there, we kind of pick up a bit of flack for these referred to as best guesses. Hope you found that useful. In the chapter links to this paper, I'll put the topics. So if you want any specific revision on a particular area, if you kind of hover over the scroll function, it will tell you what the, or in the description, it will tell you which each of the chapters links to which topics. Thank you for your time in listening. Hope you found it useful. Feel free to subscribe if you want to, and I will see you soon.